What if the very thing protecting us from catastrophic climate change was actually our own pollution? Welcome to this explainer. Today, we're diving into a profound mystery. We are going to unpack the recent communications and research from renowned climate scientist Dr. James Hansen to really get at the underlying physics of our changing climate. We're talking about hidden forces, stuff standard models might have just missed, and how this fundamentally alters what we thought we knew about our near future.
To hook into this mystery, we have to start with a really tough question. Why is global warming suddenly accelerating? I mean, why is the year 2026 seeing this unprecedented rapid spike in temperatures that has caught so many experts completely off guard? We aren't just creeping up slowly anymore. We are seeing massive leaps, and that demands a rigorous, physics-based explanation.
And just to put this into perspective, the projections for 2026 are tracking significantly higher than the already record-breaking heat of 2024. This isn't just a random weather event or a slight statistical blip. The data is strongly indicating a severe acceleration in global surface temperatures, so much so that Dr. Hansen's team confidently projects 2026 to be the absolute hottest year on record.
Okay, here is our roadmap for solving this together today. We'll hit the accelerated warming mystery, unmask the aerosol effect, dive into the 4.5 degrees certainty, talk about warming in the pipeline, and finally, look at the point of no return.
Section 1. The accelerated warming mystery. Let's step away from the thermometer for a second and look at the actual engine driving this.
To understand this engine, we have to talk about Earth's energy imbalance, or EEI. It is the ultimate physical driver of global temperature. Think of it like a giant bathtub. If more water pours in from the faucet than drains out the bottom, the water level naturally rises. For Earth, if more solar energy comes in than radiates back out into space, the planet heats up. It's really the absolute most fundamental metric for tracking global warming.
Historically, this energy imbalance hovered right around 0.6 watts per square meter. But recently, it has literally doubled, spiking to an average of 1.48 to 1.58. What that means in plain English is the Earth is trapping heat at an unprecedented, accelerating rate. The engine of climate change has basically been thrown into high gear.
Section 2. Unmasking the aerosol effect. So what changed to trap so much extra heat so incredibly fast?
Well, it involves this fascinating, yet kind of tragic trade-off. For decades, human-made aerosols, essentially particulate air pollution from factories, shipping, things like that, have been acting like a giant reflective sunshade. They've been bouncing sunlight back into space and providing a massive cooling effect. And this cooling was actually masking the true heating power of all the greenhouse gases we've been pumping into the atmosphere. And here's where we hit what Dr. Hansen calls the Faustian bargain. We have successfully and rightfully cleaned up ship fuels and reduced factory emissions to save human lives and improve air quality. But by doing the right thing for our lungs, we inadvertently stripped away our reflective aerosol shield. We essentially unmasked a hidden force of extreme warming, revealing the actual, much higher sensitivity of our climate system.
Which brings us to Section 3, the 4.5 degree certainty.
With that aerosol shield significantly reduced, the fog is lifting, and we can clearly calculate the true equilibrium climate sensitivity, or ECS. Now, the standard IPCC best estimate has long been a 3 degrees Celsius sensitivity, but Dr. Hansen's calculations, which account for that hidden aerosol cooling that masked the true heat between 1970 and 2005, reveal a much hotter 4.5 degrees. And trust me, in planetary physics, a 1.5 degree difference is absolutely massive.
And this isn't just a guess. This 4.5 degree reality is backed by 4 completely independent scientific pathways in Hansen's research. We're talking data from the last ice age, modern post-2000 satellite data tracking cloud cover, the literal physics of how Earth escaped a prehistoric deep freeze, and finally the fact that our modern warming aligns perfectly with 4.5 degrees once you account for that missing aerosol shield.
Looking at our planetary neighbors really shows us what's at stake here. Mars has a thin atmosphere and is freezing cold. Venus suffered a runaway greenhouse effect and is essentially a 500-degree hellscape. Earth sits just right, at least for now, with about 33 degrees of natural greenhouse warming. It just perfectly illustrates how a planet's climate sensitivity strictly dictates whether it remains hospitable or turns into an unlivable hothouse.
Section 4. Warming in the pipeline. Because of this higher 4.5 degree sensitivity, the math on our near and midterm future changes completely. Dr. Hansen calls this a double whammy.
Basically, there's significantly more warming delayed in the pipeline than standard models anticipated. Why? Because the aerosol cooling we're cleaning up was stronger than expected, and actual climate sensitivity is 4.5 degrees, not 3. Add to that the immense thermal inertia of our oceans, which absorb heat incredibly slowly, kind of like a heavy freight train that takes miles to stop after hitting the brakes, and you realize the heat is delayed, but it is absolutely going to arrive.
So the stark reality is this. Even if humanity manages an absolute miracle and halts all carbon emissions today, between 4 to 5 degrees Celsius of global warming is likely already locked into the pipeline. Because the climate sensitivity is around 4.5 degrees, simply reducing or even halting emissions is no longer enough to curb the warming that the fundamental laws of physics have already baked right into our oceans and atmosphere.
Section 5. The point of no return.
This demands a total paradigm shift in how we approach our future. If we can't stop the temperature from rising based on past emissions, what exactly must we be trying to prevent? Well, we have to shift our definition of catastrophe. For years, the focus has been on trying to keep temperatures below 1.5 or 2 degrees. But with 4 to 5 degrees already in the pipeline, this research suggests we will pivot to preventing the point of no return. That's the specific, critical moment where we lock in the unavoidable, irreversible collapse of global ice sheets. If the ocean's warm enough to trigger that collapse, we guarantee extreme sea level rise that will permanently alter the maps of our world.
So I'll leave you with this final, really provocative thought. If Dr. Hansen's calculations are correct, and this immense heat is already in the pipeline, how do we urgently redesign global policy? How do we move beyond just reducing emissions to actively intervening so we can survive the warming of tomorrow and prevent an irreversible ice sheet collapse? Thank you for joining me for this explainer. Understanding the hard physics of our planet is really the only way we can effectively navigate its future. Keep questioning, keep learning, and I'll catch you next time.